This
install.
conference will now be recorded.
Thanks, Anish, and welcome everybody to another Grasshopper session. We're like mid-conversation, so we were just talking about patterning. So today's session is parametric patterns, and Chris asked about one of our colleagues, Oren Sherman, who's in interiors, and yes, some of these patterning devices and things we're thinking about using in the graphic design world. Installations for wall coverings. We're doing custom guardrails and elevator finishes and things of that nature. So yeah, I'm gonna start sharing my screen. I'm gonna this is gonna be like a 3-part session. I'm gonna kind of showcase 3 tools that we've developed and we've used over and over and over again. So they're well worth their weight in development, in my opinion. And we'll do about like 20 minutes for each tool. Or less. Maybe half of that time is working through the script and the Rhino model and all that good stuff, showing examples, and then maybe the second half is 10 minutes of Q&A or conversation, and then we can move on to the next topic. The topics are similar, but they're different. So let's jump right in. All right. So I'm just going to keep this in not full screen so I can zoom pretty good. But parametric patterns. First, we're going to go through something called the graphic map generator. If you're familiar with Google Maps or OpenStreetMap data, we're basically going to use that information and populate it in the Rhino Grasshopper environment for literally anywhere in the world that has data available. So here you can see just a chunk of maps. I can't tell you how many maps I've made, dozens and dozens and dozens. I feel like I've been all over the world, but I haven't left my kitchen table. So a couple places in London, obviously our home in the seaport, something in Milwaukee, and these are all rapidly generated within seconds, and the coloration is worked through in a template in Illustrator, and you kind of have control over vector graphics in that way. And there's even information in the model, right? Like it's to scale, for example, and you can calculate the area of a building footprint or the length of a street, something like that. One of the ones, I was dreaming a little bit and I was like, oh, I had this idea to go back to Geneva, a place I've been, but not in a long time, and start to look at it in this way. So it's fun. You can put in your hometown, a place you've never been, project specific, or we could study 10 cities across the globe at scale and try to come to some sort of conclusion about density or street layout or something like that. Pretty powerful to get these quick maps. And the graphics are kind of cool, where you can start to play with figure ground, some Neolini maps, things like that, start to isolate areas. This circle and star that you're seeing is approximately a 1/4 mile radius. So that's, I think, of like a 5-minute walk. So if we're interested in what's 5 minutes away from this amazing little island between bridges, that's where you can go. And this is an example of a real project, a physical representation of translating that map geometry into something like profiles and shaded areas to run the laser cutter and to make figure ground maps. This model is approximately like 39 inches long and 20-something inches wide. We've done this kind of a few times, and it's a great way for project teams on tight deadlines or don't really have a lot of information in places like this model, and they need stuff rapidly generated, otherwise not necessarily available. So with that, I'm going to jump over to the Rhino side of things, and here we are in sort of like, plain old Rhino world. I just opened it and Grasshopper, and I'm going to go to our parametric patterns folder where all this stuff lives, and let's get into Rhino and the graphic map generator number 1. Just drag and drop and say, yes, please open that file. In this file, in the layers, you'll see I always typically have a working layer. That's usually where I work, and then there's this center of walk, which you'll also see this point here, that looks like a dot, and all these building and road and highway leisure, they're layers, and they correspond to what's going to be happening in the Grasshopper environment. So nothing on screen at the moment, of course, and we'll just jump right over and open up our, oops, went too far, our Grasshopper script to go along with it. All right, so here's the graphic map generator number 1. drag and drop. And just really quickly, I'm going to walk you through what's in the script. Okay. So this script uses some components called ELK. It's basically taking OpenStreetMap data, imagine it like a huge Excel Word document, and you want to find things. You want to find things in this big data set. And the way that you find it is by using call words. A call word could be highway, could be minor roads, things like that. That OpenStreetMap has dedicated a very specific term, and we're just saying, find me those terms and populate geometry for me. So your input is literally one thing, which is a OSM file. And we download that from openstreetmap.org. I've downloaded a bunch, but I think we should go somewhere kind of together, and that'll be more fun. And here's a little generator for that point, which creates a circle based on a very specific dimension to get you that 1/4 mile radius. So we can move that point around in the space, and this circle will move around with it, depending on where we want to see how far 5 minutes is from any given point of interest. I don't want you to get too hung up in what's happening behind the scenes here, because these scripts should be able to like open rapidly, use rapidly, export rapidly, and be on your way without really having to dig too much into the logic of Grasshopper. That's one of my goals in creating firm resources. So over here in the output is really where you go after you just input that one piece of data, and you're going to see things like building, and natural, and leisure. And we're going to be baking from the preview to those preset layers that have preset colors, and then all of a sudden we can start to bring that stuff into a graphic program like Illustrator. All right, so let's get started. Looking for an OSM file. So I'm going to go into Firefox here and go to Google and type OpenStreetMap. And I've been there a bunch of times, so it's openstreetmap.org. And oh yeah, I'm in Hawaii right now. But does anybody have a place they'd like to go? Nobody? No wanderlusts? Anybody?
My basement.
Pardon?
Can you spell Reykjavik off the top of your head?
Can I spell Reykjavik? No, but you can.
Yeah. It's like Reyjavik or something, right? Yeah. Oh, I just spelled Reykjavik.
I can.
Oh, the
I
K,
can
the silent K. Sorry, yeah.
So the idea is that we're just going to zoom into a piece of Reykjavik. And I like to get a little coastline, a little green space. Maybe I'm interested in actually like this monument or whatever it is. I'm not very familiar, but pretty simple to just go export, export. And here's a save file, comes up, you say, yeah, I'm going to save that. Thank you. And it goes into my little download box here, and I'm just going to open that folder. And it's called map 42 because I've downloaded 40 something maps. But I'm going to take it and copy it, and I want to put it back into our folder structure to save for later. And paste it in here with Geneva. And I'm just going to call it Iceland because I'm not even going to try at the moment. I'm going to get that file path, right? And then back in Grasshopper, now I know that I can right click and select one existing file. And the reason I know that is because it's sort of written. So it says right click and select one existing file. Here we go, set one. Where do I go? I'm just pasting that location that I copied, and I'm going to click on Iceland. I've never been. I would love to go, and maybe I want to do a little research before I get there, so I can check out some maps, make myself some walking patterns, and oh wow, Joey broke it. Perfect. And maybe I want to figure out my walking distance from my hotel, or maybe I want to make like a cool map on a laser cutter as a gift for myself. I've been here, you know. So here we are. Again, nothing is really live. I'm going to take this point and I'm going to move it to my center of locale. Okay, and then I could go along and start to bake these layers. So I'll just do this building layer, right-clicking, bake. You'll see all the layers in the document come up, right? And we're just going to choose the same word, building. Awesome. Sometimes I like to just do like Control N, which gets me a new document here. It's also, you know, file, new document. And that way it just kind of turns off the script for a moment and I can see what I've done. there's all my building outlines. They're super cool and clean, and they can be exported directly to Illustrator. So what I'm going to do is I'll just go backwards a little bit to show you how easy it is to do a different place. Cool, I like that. Iceland idea. We'll just switch it up. We'll go to Geneva. And this is because I've pre-built some stuff. So over here, all the light bulbs that are turned off. I went through the process of baking those. You know, probably takes about a minute or two. And it's probably pretty important to get your scale. So I'm gonna move my dot back. Again, go to the other one. Control Tab here is what I'm using to flip. I'll turn on all of these objects. There they all are. And we'll go and bake the buildings, which is the only one I didn't do, just again, for a little repetition. Right click, bake, building. Boom. I'm sort of done with my script at the moment, and I'll just minimize that. And what I'm left with is a whole bunch of geometry. Right? Oh, last one. I really want my circle in there. So I'll go to my circle and I'll right click and I'll bake that to center of walk. Awesome. And here we are. If I select all this geometry, I'm in a millimeters file. You know, Grasshopper likes metric, but I'm all to scale. So I'm gonna go, I copied everything. I'm gonna go File, New. I'm not gonna save my changes. And I'm gonna go into small objects, inches. I'm gonna paste. It brings in all my layers, everything I just did. It's still selected. I'm typing scale from 0, 0, 0, and I want a map that's 1 to 200. So I'm gonna go 1 over 2400. Now that scale factor is 12 times 200 to get us down to something that's gonna fit on a piece of paper, right? Because that's really what I wanna do is make a drawing. Here's all my stuff. If I draw a rectangle from 0, 0, 0, and maybe I go like 48, oh, that's big. All right, 24 inches by whatever you want, right? 14. Whatever your page size makes sense. So you'd select all that stuff, and you can export it by going File, Export Selected. In your file type, you want to choose Illustrator. I'm going to go, I made a whole bunch of them. So I'm going to show you, what it looks like raw. And I just saved it out as something called Geneva graphic map _1 to 100. This is a 1 to 100 one. You can do any scale you like. And you'd say save. So I'll just say test 1 to 2. Save. You can either do a snapshot or preserve the model scale. Since it's to scale, I'm in the top view. I just want to get a scale 1 inch equals 1 inch drawing out of here. So I'll say, okay, I'm leaving. My coloration is CMYK, and off we go. Let's go into the file structure again, where I'm in Illustrator. And I'm just going to open the 1 to 100 version. It's about the same. So when you open it up, it might come in a little off center depending on where you are. There's a nice big rectangle on this one where I can start to locate it on my page. This is a 36 by 48 inch piece of paper. It's a 1 to 100 drawing. And you'll notice over here that all the layers came in from Rhino. I haven't manipulated this file at all. That's all raw. And I'll just select all the buildings and just for fun, flip them dark. So that's a great way to start getting some diagrams and things going for ground maps. And of course, if you wanted to, again, go back to some of those samples, we can get you to somewhere in a new graphic styling, multiple cities at a time, whatever you really want to do to overlay information on top of these. Cool. That's sort of graphic maps in a nutshell. Anybody have any questions, ideas about it? Things that they'd like to see, or did you think it was cool?
I have one question. So, have you seen any problems when the map gets large, um, having footprints be relatively accurate? So when you
Um,
start, so when your map gets large enough that the Earth is curving, that if we're trying to do, I don't know, some kind of architectural thing using a large map, that we're not running into problems with how it's going to smash or flatten.
no, yeah. I guess the maps are all generated two-dimensionally. They don't really have any 3D data at all. I've never done enough land area to think about curvature of the planet. I
Yeah, I
guess the
don't know what
largest,
scale it starts at. I know it's smaller than at one point I found out it was smaller than I thought it was. And it's still relatively large, not like 3 blocks, but a map of Boston definitely would have issues um, if it's like a GIS thing based on satellite image versus something that's like measured out by Boston Water and Sewer.
I see. Yeah, these should be taken at sort of a really high level aerial view and make big general assumptions about city grid layout, for example, or what people do with their coastlines. You know, green space in coastline areas versus something like a giant highway or a roadway or a railway. You know, I
So
can't
just
see why
diagrammatic.
they are diagrammatic. To my understanding, this is like the best information we have directly at our fingertips without getting into like GIS data, for example. So they're big diagrams. David asks for them a lot when he wants to compare certain metrics of cities around the world. Um, when you just want like a graphic map, like something that a graphic designer would do and start to put like amenities and color different types of program and start to develop like a storyline around a neighborhood, these are perfect for that because they're light and nimble and the graphics are easy to change. You don't really need GIS or anything more specific than that. You just need to kind of do the work and overlay, which is actually the work. You know, we don't want to spend time tracing maps and tracing stuff. You know, back in the day, I was working on the Boston Olympics, and we used to trace parts of the city, you know, from scratch to Google Earth. It took a lot of time. It left some shorter amounts of time to actually do the planning and the design around those spaces. But that would have probably been a pretty cool tool to get, even if we could just look at like context buildings around the neighborhoods as a general organization and the geometry. That tells a nice story for different parts of the world we're trying to look into.
And have you seen any map sizes that get a little bit tricky for Rhino or Illustrator to handle?
Yeah, I've made the entire city of Seattle. Oh no, Chicago. I made the entire city of Chicago once. That's the largest I've ever done, and I didn't put any like analysis on it, but I was
I guess
definitely
it's
able
just
to.
more experience, like if you're trying to manipulate it, whether things got slow or there seemed to be a lot of CPU bound events happening.
Not with 2D line work, honestly. You know, all this stuff is just lines. There's no real geometry in there. So I guess the one constraint that I've found is if you're in OpenStreetMaps and you try to zoom out to like the entire United States, it's not going to give you the entire United States all in one go. So there is like sort of a max tile that you have to grab, and then you would have to move yourself sort of north, south, east, west, or in a diagonal manner to tile your own city, and that can get a little tricky because you need to stitch it together, right? Like almost like a big mosaic. So when people say I need 6 mile radius city, I'm like, okay, that's going to take a little while because it's not just one grab and go. You need to do 12 tiles or something.
And when you do that, the stitching is straightforward. There aren't any weird mismatches.
No, it's very straightforward because you're basically using the building footprint of the adjacent tile and just lining it up because usually they overlap. Like a building will be repeated.
Yeah.
And so when you put those two on top of each other, then you can do a command called like select duplicates and all those, so you don't have like double buildings.
I would just add that OpenStreetMaps is, you get what you pay for. Sometimes good for sort of planning scale, but don't really take things from a given site to be too accurate. It basically will not give you accurate street edges. It goes off center lines and it makes some guess about the width of the street, primary, secondary, tertiary. And there's values for what those are, but they're not necessarily specific to that street. So you really can't, it might be within a couple of feet, but you can't, assume that that's your site plan now.
Correct. That's 100% correct.
Parcel.
And that, let's be more specific about why this tool was developed.
Large scale stuff, bridges and other features like that. Again, you get what you pay for. It's a good first blush. You should work.
Chris, you're a little choppy, I think, unless it's just me. And I hear you 100%. I want to reply to you and then continue moving on. I was working with the graphic design department on this tool specifically, and they were using OpenStreetMap data to download PDFs, to manually separate those PDFs in Illustrator, and to get this exact output in a manual way. So the idea was to automate that process. One map could take days to a week to generate, and now we can make about 10 maps in like an hour. So that it was an automation exercise for taking something that was taking a little bit too long from the designer's point of view, and said, this is a pain point for us. What can Grasshopper, what can scripting and automation do to help get these things out faster? So we'll never go back to that manual PDF download and extracting OpenStreetMap data in any other way. And I wouldn't say that OpenStreetMap data should be used in architectural design for a particular site or place. It's just not accurate enough. And also that these are called graphic maps for a reason. They're graphics, and they're able to be seen as graphics, artwork, and not surveys, not data to rely on really for any building metrics. But graphics and maps are just amazing tools. So.
It's kind of like lagging on you, Chris. Maybe if you turn off your video. I don't think we heard.
Should we jump to number 2?
Let's start next thing.
Cool. Back to the share screen. Number 2 is something we're calling lattice patterning. Lattices are very small sort of modules that get populated in between space to create really strong, lightweight, and otherwise, not solid parts, or in this case, patterns, because they're interesting in the way that they can be brought into Illustrator again, colored. You can imagine this as a feature wall or something that runs around like a kitchen or what have you. Maybe I'm not the best color artist, but that's why I have my friend Oren Sherman, who's a color specialist, to help me out. And then things that are extremely complicated and able to be developed again in seconds, where something like this, to draft it in any other tool that we have, you'd be like painstaking to do it. And we can make iterations of complex patterns. If you don't like this pattern, that's fine. But there are about a bazillion patterns that I'm going to show you. You can export from one little toolkit. And a kind of an abstract example of that is this 3D printed chandelier we did. It's about 1 meter tall. It was printed over 9 days, and Joe Kyle had the amazing honor of running that machine and operating it the entire time. So this is a lattice pattern that's being developed. It will trace the geometry. This is sort of a half sphere here to a point, and it's filling in with the density and a geometry and a pipe structure, all chosen by the parameters or by the designers, me and Joe. So being able to make these geometries, we made about 8 or 10 iterations. We were able to print and prototype our smallest one and then make a huge chandelier that we have in our office today. Back to Rhino. I'm going to go into our folder structure, and I'm going to open up the Rhino lattice pattern platform or template. I don't need to save any changes. Those are all for you. Here, I'm just going to go, we're zoomed in for a reason. I'm going to close out of that other one. Don't need that. And we'll bring in our Grasshopper. So here is the module, right? It's not selectable. It's all previewed. And this is a very tiny script, super tiny. And it's called surface to surface. And you know a little bit about Grasshopper, where you're like, okay, I need two surfaces. What's this thing? And some divisions and things we're going to talk about. This preset cell is built into a toolkit called intralattice. So somebody went through the trouble of building all of the sort of lattice modules that exist in the world today, and you can easily flip through them and preview their geometry using this value list component. I'm just going to undo it for a minute. Oh, that's cool. I didn't think that was going to happen. I thought we'd just see what a value list looks like. Wow. Something like this, where it has no data, but if you plug it into something like a preset cell, it pulls all the information and you can kind of cycle through it. Pretty fancy stuff. I'm just going to turn this preview off by right-clicking preview off. And I'm going to zoom extents in the Rhino document where I have two pretty wild surfaces going. Surface 1, I'll select, I'll right-click, set one surface. Surface 2, right-click, set one surface. And now you see that there's this sort of geometric web that has automatically been generated. I'm going to hide my two surfaces, and we can experience this object in 3D space. We can experience it in plan, which is something more regular, or all of our viewpoints if we wish. So pretty futuristic looking geometry, and these little sliders will start to help us develop some more specific moments. We talk about moments as sort of parametric processes having a lot of motion, a lot of options and iterations. And when we stop this thing at a time and sort of freeze that moment in time, we're able to extract that. So there's a good storyline there. So if I go down in the U count, it's sort of dividing less times, right? Which is why the shape is getting more open. Maybe look at it on top, more like a spirograph. So here's sort of a density. And what I really like is the moments where things start to collide or disappear at vanishing points, and all these curves start to collide. And we can talk about density in multiple directions, right? Some things might get pretty strange, but it'd be amazing. So something like that, I find pretty cool in deer. So maybe there's this frame I'm very interested in. And what I can do is have a little new pattern layer, and I'll go to the end and I'll bake it. And I'll say, yeah, that's where I want to keep it. And let me go to the other side here so I can get a fresh look. And very simply, I can take these again and export them just like we did before to Illustrator. And I have a few lattice patterns that I was working on. And those just come in as vector lines. So you're able to be back in the Illustrator world. And I'll just open up, I think, the raw version, which again looks something like this, right? And what you can do is you start really sculpting. This is about really having fun and being playful and being able to sculpt with geometric forms and patterns and not really being constrained to any sort of bounds besides your own imagination. You know, taking lines and changing their color or their stroke weight is quite easy, and you can go in and start to do things very specifically if you like, right? Different colors, and then adding things like colored backgrounds or gradients or anything you wish. So a cool way, and all this geometry again can be sort of prepped, primed, and you could do engravings in materials like glass and stone and tile, wood products, acrylic products on a laser cutter in the office. So that's cool. And one last time, back to something crazy and looking in a little window and being able to see, vector geometry at its greatest form. So perfect, so pure and clean. That is our one of very many lattice patterns. There's an instruction booklet that goes along with the plugin kit intro lattice, and there are dozens and dozens of really exciting ideas in engineering and pattern making and auto populating very complex parametric geometries. Any ideas there? Does anybody do any complex patterning or wish that they had access to patterning? The next tool I'm going to show you is, I think, one of the ones we've used the most and makes the most sense for some very tricky things in design that are hard to draw, just by nature of the mathematics. So if nobody has any questions, I'm going to jump into part 3, which is what we call the halftone generator. On the left, you'll see some example, just pattern output. We're working on dot patterns at the moment. I'm going to show you how to manipulate that to a different shape. You know, the portrait is a pretty fascinating example. And again, if you zoom in, we're just looking at pure, perfect circles that can be crafted again or colored again in Illustrator. You know, using Illustrator and Rhino is something I love to do because you get the vector geometry working in both ways. Rhino opens Illustrator, they work really good, vice versa, and you can start to really make some powerful graphics that way. The one on the right is sort of a gradient. I know you probably see like a hard line somewhere on this, and it's because your computer screen can't really show you gradient. It's really hard for that to happen. So I'm just going to zoom in on where I think the hard transition is, and you can see again that these dots just continually get smaller and smaller and smaller. There is no hard line of transitioning from one diameter to the next. It's a constant transition across the plane. Want to have a little fun? We can add things like color, big graphic murals. You know, maybe that's important to one of our fun hospitality clients. But even just having a little bit of fun with the angle and the motion and the direction of these things can be pretty powerful. Here's an example of a real world project where we did a dissolving rectangle. So we're using squares instead of circles and using a gradient, in this case, left to right instead of top to bottom, and lining the, I forget how many stories this is. We did a few different colors and a few different staircases, and they were sort of applied to the wall. This is in construction, but pretty cool. It looks pretty sharp. Nice and clean. Vector graphics, again, able to scale and meet big areas, but still have that crisp precision of clean line work and colors. We're going to go back to Rhino and back to the folder structure and a new template, halftone generator. We need to save. Load. Over here, I'm just going to get rid of the lattice patterning. I'm not going to save, I don't need to. Grasshopper again, and we'll find our generator. Let's hold on that for a second. Let me show you what's happening in the Rhino environment first. Where are all these circles, right? Yeah, that's free to call out, right? Seriously, it's free to call out. And it's thousands and thousands and thousands of circles. In fact, it's 51,353. And they're all at different diameters, right? And the idea is something called image sampling. So we're going to talk about image sampling in the way that portraits or abstract geometry, like imagery or textures, gradients, all these things can be interpolated into geometric patterns. It's pretty fun. So we'll just get rid of free color for the moment. I'm going to zoom extents, and there's a circle. That's what runs the whole thing. It's just one simple circle. We're going to go into the Grasshopper environment, and we'll open that script now. Okay, I have it loading an image as it's opening. is that gradient. And I'm going to just walk you through quickly what's happening. Again, sort of ignoring everything in between. It's not something that you actually need to understand to use this thing. Talk about width and width count. First and foremost, that's just like sort of a pixel count or a length to width based on your units of measure. So right now I'm in an inches file, so it'll be 40 inches by 40 inches. My count is how many samples across the image. So where those center of circles happen. So right now I have 80 in either direction, meaning I'm at about like a ½ inch on center grid, right? That's pretty important if you want to be specific. You want to be really specific about, say you're making a custom guardrail and there's code and you need to know how big these things are. We can do that. And 40 could easily be 36 inches. Height could be 42 inches for a panel shape for a guardrail. And you can divide your counts to make some sort of graphic, which we've done. The input image is a gradient for the moment. We can change it to, again, sort of anything we like. I'm going to show you how to play with it in live manipulation and do some pretty fun stuff using Photoshop. I know everybody's like, wait, Tom uses Photoshop? Oh my gosh. But yeah, I like Photoshop too. I like photography and things. So here we are down in the last input. These are where the circle is plugged in. But again, if you use the template, you don't really need to do that. It's already built for you. The margins are built for a pretty good resolution and the minimum. So this is like, my minimum circle and my margin. So when those two things interact, you get your minimum and your maximum diameter. So if I change any of this stuff, I'm going to know what my minimum and maximum diameter of the circle is. And that's really good for code purposes and things. We don't want spheres of a certain size to pass through any holes, for example. There's also minimum dimensions we need to stick with for certain manufacturers' products, even print media. And then all the way over here is just the output, which is the preview of all those circles where you can bake it, select it on its layer, and export it at scale or at a snapshot to Illustrator. So let's see what's happening just from opening the file. If you were to open the file, you'd see all these black circles. There's nothing there, right? It's all preview geometry from Rhino. And I want to play a little bit with my graphic. So back to the folder structure, where I've put a folder called input imagery. And here's a linear gradient, and I'm going to open that with Photoshop. So here, if let's just do something like control, maybe I'll image transform. Just double click the layer, control T. And maybe I really want the gradient to be in that direction. And I'll hit enter to save that change. And to make the point across, this might get a little hairy, lots of tools. Cool. I just want to show that if I do something wacky in Photoshop, it's going to show up live in this drawing. So let me just say save. It's going to say, what do you want to do? Where do you want to save it? And say, yeah, my input imagery, that same file I was just working on as a gradient. I want that one. And I'm going to overwrite it. And I'm just going to watch this change. Saving, pretty heavy file. Just about 4 feet square, which is no small area. And there we go. So that's pretty cool. I can change the gradient if I want. Change things like the contrast or the tone. I can have it be color, but it's really only seeing black and white. But one fun thing I think that like Joe and I and Manish were working on is saying, oh, can we like do something strange to it, and then what happens to it, just to get the point across that any sort of odd geometry can be dealt with. We'll save again. I was just erasing, right, just for fun. Wonderful. Let's see what happens there. Thinking about it. Probably getting over to the Grasshopper world. Ugly. That's not so cool, but it is really cool in the same way because it's picking up white as these big circles. This is our input circle, right? We know that But what if we did something to it? What if we wanted to sculpt it more like a moon shape or something? I could build a whole new shape, but just to get the point across, I don't want to be on grid snap right now. We'll just sculpt this into like, oh, you know, whatever shape that is. Kind of like a Pac-Man. Well, now they're all Pac-Man, all of them. So if you think about stars, you think about circles, squares, any sort of polygon, even something organic like a graphic would be pretty cool, like an icon. A giant pineapple made out of pineapples would be kind of fun if there was a client who is very interested in pineapple shapes, which is awesome. And then one last thing to drive it home is I wanted to try and look at a more complicated image. Pulled one off of Shutterstock, which is something we do a lot if we need imagery. I'm going to open it in Photoshop again, just kind of see what's happening here. I'll go to image size. It's 3600 by 2400 pixels, or 12 inches by 8 inches. I like to work in the pixel world, so I'm going to say, just to keep things simple, I'll be at 360 by 240 pixels. Back over to Rhino. Why don't I set that image? There we go. It's going to look a little strange. And the reason for that is it's not proportioned properly. I'm also going to undo and go back to a circle. So what I need to do is to proportion it properly is say, what were those values in Photoshop? 360, 240. I'm just truncating that last zero. I don't need that much information. The height, again, 240. And if I take something like 360 and divide it by 2, that's a 2-inch grid. I'm 180, 120. And now if I zoom out, I have this sort of abstraction of water that can be brought in, again, and baked in Illustrator and to do graphic imagery with something like water. It could be, again, like something we put in a lobby space or on some feature walls in a new seaport building or any building on the waterfront for that matter. Water movement is sort of a fun storyline, especially when you add some computer graphics. Say we're working with a lab client. Could work. Has worked. And I think that might be everything in my script world. Maybe I'll show one more example of what that looks like in Illustrator. Don't want to miss that portion. That might be good to go. So here's the gradient. If we were to export that, and what I've done is color it. But when you bring it in, it kind of just looks like circles, and you fill them and you start to do things with the coloration, which is kind of nice. You can also make the masks, you know, and all. If you're good with Illustrator, there's a plethora of things you can do and have a lot of fun doing it. Be about stopping the share. There we are. How'd I do? Did I miss something huge? I have this like crazy outline that I developed, and I was like, I'm gonna look at it, and I'm gonna go through step by step and check these things off as I go. I didn't look at it once. I think I memorized it.
Practice.
Yeah, we practiced it a couple times, which is good. Get the story straight.
Look great to me. Sometimes just making a list helps you make sure that you have it organized in your head.
Yeah. The one dry one I did with Joe and Anish just the day before yesterday was all about sort of outlining, getting it organized. It's a lot of stuff, but I was gonna say, try to like do it live and make a map. I really just didn't want you like watching me click around that much. That can get kind of boring. But I did do this in an afternoon, and I know I've used the tools a lot, so I'm not expecting that everyone's going to do it this quickly. But I did one exercise in each script and got all the way through to a graphic and put it into that slide deck like I showed you, probably in like under an hour or two. So each one of those used to take a week, right? Even the halftone generator, that used to take days, if not a week, because of the tools that we're using in Photoshop, which doesn't get you vectors unless you do like paths, not so hot. And Illustrator, which took a lot of computation and a lot of time, and you actually didn't get perfect circles. They became like little blobby sort of shapes, which was strange. It also can't do perfect gradients and things. So I worked on a halftone project with a colleague and a client who wanted to put a perfect Frit from this glazing plane to that glazing plane. We couldn't figure out how to draw a perfect Frit. So that pushed me to like learn how to do a lot more with this tool. I was like, I bet you image sampling can make a perfect gradient circular Frit somehow. Give it a shot.
Yeah. So what's that workflow like, right? Like, was it really just kind of like you and Oren kind of scheming, and like how do you kind of ideate all that?
Like for the architecture or for the interiors?
I guess the interiors, because I don't necessarily see the interiors people do. I mean, I don't know. Did they come to you with the problem and then it's like, how do I solve this problem? Or is it more like an active kind of, what can you do kind of situation? How did that conversation go?
All of the above. Sometimes there's a need for another design idea. Sometimes there's a quick need for something, and more times than not, people might come by and ask if I could help. So in the interiors world and the architecture world, some colleagues of ours came over to me and said, hey, I have this thing. I thought maybe you had an idea on how to help. This happens a lot. And I said, great. Tell me about what you're trying to accomplish. Tell me about the application, and what's the information you're trying to get across. Tell me a story so I can sort of continue in on that story. So in a graphics world, it's a lot about art and speech and writing. A lot of romanticism goes into it, where we talk about visualizing water in different ways, and we've even talked about how do we visualize the surface of the water, not the air and not the water itself, but that cusp, and not only in one location, but across an entire wave or entire water body. So I get that prompt. Somebody says, how do we do that? And I say, oh, I don't know, but I think I want to make a wave, and I think I want to contour it, and I think I want to then just look at the line work in almost like a section perspective and put myself right at that water level, and then snap all those lines, bring it into Illustrator, give that over to my friend Oren, who will do a plethora of color studies, gorgeous things. I cannot do color as, not even close to what he can do. But we work really well in that way, because I'll kick it to him, and I already know what the size and shape needs to be. Whether it's a wall, I know the length and width. If it's a tall stair, I know the interior elevation. I get those things first. So I'm working at scale in space digitally, and I'm giving those things at scale in space so he can apply his magic. And then it goes into documents for reviews and approvals. And eventually the artwork that we've developed, especially if it's high resolution quality and vector art, we give that over to the print company, depends who that is, what we're making, and then they'll print and install with contract. On the architectural side of things, a little bit more specific, because there's a lot more data. It's not as romantic in sculpting and sort of freezing time and playing with line weights and color. Both have very, very important places in the world of architecture and design, in my point of view. So I would get an elevation, like a piece of glass curtain wall, isolated, just sort of that thing that we need, and maybe some pieces and parts of buildings around in its context that might have a troublesome effect on, like, casting shadow, for example. We want those unique conditions in our analysis models. So I will, again, work with the length and the width and the daylight opening of the glazing, because I don't want anything in the pocket or on the pressure cap or on a butt glazed mullion. So you sort of have to work in between your constraints, start to understand a grid size, and at the same time, you know that you're creating a pattern, but what are you measuring, right? You're not just measuring how to put a frit onto a glazing element. You're measuring the performance of that frit as it pertains to something you're trying to solve with, let's say, solar gain, right, or daylighting or something. So we have added on to the halftone generator things like ladybug and honeybee tools, where we can push the sun through this glazing plane, have the frit block it, and study what that frit pattern will do for something like the floor surface in your new beautiful main entry lobby. And that generation of the pattern goes directly to the manufacturer because it's perfect circles, they're at scale, they're supposed to be where they're supposed to be because they're coordinated with the overall assembly of the curtain wall system, and those things go direct to manufacturing from our pattern. Because again, nobody's really making perfect gradient patterns that are broken at curtain wall joints and so forth.
Very cool.
Thanks.
All right. I mean, I think we're maybe out of questions, and I think we're close to 2. So I guess we can wrap it up. But yeah, I mean, thanks for presenting, Tom.
Yeah, thanks for everybody for joining. It's always fun. I appreciate it.
Yeah, awesome stuff, really.
Thanks very much. Very well, very comprehensively assembled, and really sort of opened up some ideas for people, I think, and planted some thoughts. And very good. Thank you.
Thank you, Chris.
Yeah, good job, Tom.
Go, Tom.
And I got a question for Joe. Joe, are you trying to grow like the bear behind you?
That's his dad. What are you talking about? That's not it.
Keep looking at Joe and the bear, and I'm like, which one?
Role model.
Goals.
All right. Have a good afternoon, guys.
All right.
You too.
Take care.